Hey guys, Mr. B here again, bringing another math video. In this math video, I'm going to talk a little bit about something in calculus you often run into called implicit differentiation. So an implicit function is when you have something that's not solved y equals. So you probably have most of the functions that you've probably dealt with up until now in calculus have been explicit functions. So y is equal to 2x squared plus 5, whatever, right? So an implicit function doesn't have a y equals. So that makes it a little bit harder to take the derivative of. So we have to sort of use, a little bit more care, I'll say, because actually these derivatives aren't that difficult, but they do take a little bit more finesse, I'll say. So the first thing that I usually do is I rewrite my question that I get from the, from my teacher or whatever. Or if I'm doing it in class with my students, I usually show them that I want to show the person that I know I'm taking the derivative of this guy with respect to x. And that's really important. So that's why I show this step. So the next step is to actually take the derivative. Now what we have to be careful of is that when we're taking the derivative of something that's not x, we have to use the chain rule. So for example, the derivative of u squared, for example, you've probably done the chain rule, so the derivative of u squared would be 2u times u prime. So every time we take the derivative of something with y, we get that u prime that's hanging out to the end of it. So we need to make sure that we consider that. So we'll see how this works. So we take the derivative of x times y, so that's the product rule, so the derivative of x is 1 times y plus x times the derivative of y. So the derivative of y, just like in every other derivative that you've done, is y prime. Like when you take the derivative of, say, y is equal to x squared, that becomes y prime is equal to 2x. So that's the exact same scenario. You take the derivative of that, it's just y prime. Minus, now the derivative of y squared is 2y times y prime. So we got to make sure we tack on that y prime at every time we take the derivative of anything with respect to x, if it's y. So then take the derivative of 5x, which is just 5, and 1 is 0. So there we go. So I'm just going to rewrite it because I want to get rid of this bracket here that I have. So I have y plus xy prime minus 2y times y prime is equal to 5. Then what I want to do is keep my things that have y primes on one side and then everything else that doesn't to the other side. So I'm just going to subtract y from both sides. So I get x y prime minus 2y times y prime is equal to 5 minus y. Then what I want to do is take out a y prime from both. Y prime, I'm left with x minus 2y is equal to 5 minus y. Then I will divide both sides by x minus 2y, just like that, and then I have my derivative. So y prime 5 minus y all over x minus 2y. So let me just recap this a little bit. So we take the derivative of both sides. Then we want to be careful. Any derivative rules that we normally would use, like this for example, is the product rule we have to use. Once we get the derivative done, we simplify where we can. Then we want to group our y primes on one side. I usually go left, and then everything else without a y prime on the right side. And then I want to factor the y prime out from that side that I have the y primes on. And then whatever's left is left, and I divide by that particular thing, and then I get my derivative. So notice this derivative has y's left in it. So that's going to happen. That's just a reality of implicit differentiation. Alright, let's try another one. So this one kind of similar. So I have x times y is equal to x cubed minus y cubed. So again, notice no y equals. This is implicit differentiation. So d over dx, x times y is equal to d over dx, x cubed minus y cubed. So I'll take the derivative of this guy, so it's the same as before, so it's 1 times y plus x times y prime. And then it's derivative of x cubed is 3x squared minus derivative of y cubed is 3y squared times y prime. So again, that little times y prime, so important. So I'll simplify this again. So I have y plus x times y prime is equal to 3x squared minus 3y squared times y prime. So I dropped the 1. Not that you couldn't probably do a step without it. So I notice this does not have a y prime in it, this guy right here. So that's going to go to the other side. And this has a y prime in it, so that's going to come over here. And again, the side that you put it on might be optional. So I have x times y prime plus 3y squared times y prime is equal to 3x squared minus y. Take a y prime out. And then I'm left with x plus 3y squared is equal to 3x squared, minus y. Divide both sides by this guy. And then I'm left with my answer. So y prime is equal to 3x squared minus y all over x plus 3y squared. Alright, so there it is, guys. That is an example of 2 examples of implicit differentiation, so sort of a basic introduction to it. Check out some of my other videos. I'm going to do a few derivatives with some trig involved. Thanks for watching, and I will see you guys in class.